All right, boys and girls of all ages. Oh, I got to go this way to make it this way. So this is my whoa, I'm an angel. I'm an angel of the calculus. All right, so we're going to do the substitution rule part 2. So this is different because it's a definite integral. It has definition. So we're going to go from 0 to 3 on this one. We have to figure out how to handle that situation. I am recording. Okay, that's good. And you can see me here in the corner. And I'm giving a shout out to Gabe, who's at home today. Hi, Gabe. Oh, I put this on my face there. You go coochie coo. Okay, are we ready? I was tickling my chin with the mouse here. All right. This is fun. So the first thing we want to do here is we want to think about this as having an invisible 1 right there. So we want to look at it as 1 over 5x plus 1 dx, integral 0 to 3. So what do you guys want for the u substitution?
5x plus
1. The bottom part here, the denominator. So u is equal to 5x plus 1. When we do that, it makes it 1 over u. And what's the antiderivative of 1 over u?
Natural log.
Natural log, so it's going to be natural log, right? Okay, so now we have to substitute in for the dx. And how do we do that? Take the derivative over here. So du dx is equal to 5. Then we got to use the double switch here to get dx by itself. So I'm going to multiply the dx over, and I'm going to divide the 5 back over. So it's going to be 1/5 du is equal to dx. So I multiplied the dx over, and I divided the 5 back. So the 1/5 comes out to the front. That's probably the easiest way to handle that. The du here. Now, we have to 100% switch this. This right here is in terms of x, and this is in terms of x. My limits of integration are 0 to 3, which are x values. So I need to switch those to u values. Well, guess what? I have this little key here that can translate things from x to u. So if I put 0 in for x, then I can get u back. So what happens when I put 0 in for x? I get 1. So I'm going to change the limit of integration from 1 to, now I'm going to put 3 in, because this is an x value. So then I put 3 in, and I get 16. Now, the area underneath this curve is the same as the area underneath this curve. And to compensate for that, instead of going 0 to 3, I just have to go farther. I have to go from 1 to 16. And then to compensate also by dividing by 5. That it's the same amount of area. If we look at the two curves and how they would be represented geometrically, it's the same amount of area. Well, here's the deal. I'm just looking for a number answer this time. I'm not looking for an antiderivative. So what I have to do, I forget that I can see myself. Anyway, what we're going to do is we're going to draw a line in the sand. We'll make it a pink line here. I don't have to go back and put x's back in anymore. I've completely switched this to the world of u. So I'm 100% in the world of u. I don't have to go back. All right. So I don't have to put the u back in. I just start over like it's a brand new problem, because I've switched everything completely to u. The limits of integration are u, everything. And we're looking for an area under the curve answer. Okay, so let's get it. Antiderivative, natural log, absolute value of u. Now, I don't need the absolute value because my limits of integration are from 1 to 16, which are all positive numbers. But, and then 1/5 in the front, line, 1 and 16. Okay, now I just got to plug this stuff in. 16 goes in first, so it's 1/5 natural log of 16 minus 1/5 natural log of 1. Natural log of 1 is 0. So the answer is 1/5 natural log of 16. Or you could say natural log of 16 divided by 5. Or, what's the number in front always? With logs and natural logs, what's this number in front represent? The exponent, so it's natural log 16 to the 1/5 power. You could write it like that. Okay? And the 1/5 power is the 5th root, right? So you could write it the 5th root of 16. You could write it like that. So there's all different ways to represent the answer. But my point is, we don't have to put the x back in like we were doing before. All right? Okay, second example. Any questions on that one, my people? And go. Okay, example 2. So we're going from 0 to 4 on this function here, x divided by the square root of 1 plus 2x. Let's see, are we still recording? Yes, we're still recording. All right, what are we picking out for our u? One plus 2x. Now, that's going to be good because I'll have to substitute in for this x dx situation. So we got x dx. So that'll come out of, oh no. No, it's not going to. This one's kind of tricky. Aha, that's why I'm going over this one, because this one's kind of tricky. I remember this now. All right, so here we go. Take the derivative. Du dx is equal to 2. Double switch. 1/2 du is equal to dx. So I multiplied the dx over, I divided the 2 back. And I can switch the limits of integration. So here I go. Antiderivative. I put in 0. 0 is my first limit of integration. I put it in here. What do I get back? 1. Put 4 in here. 9. So I'm going 1 to 9. Now, this is going to be over the square root of u. I need a 1/2 in the front and a du, because that's what x dx is equal, or x is equal to, sorry. X, or dx is equal to 1/2 du, so I got that done. But I don't have an x dx, so I can't substitute in for x dx. I have to substitute in for x. So what can I do to substitute in for x? Do I have something that x can be related to in terms of u? And here's my big hint right there. Okay, so I'm going to switch this around here. I'm going to say subtract the 1 over u minus 1 is equal to 2x, and then divide by 2. So that's what x is equal to. That is like a 1/2, and then it's u minus 1, right? I want to do that because I can take, that's another constant I can take out to the front. Agree? So I'm going to substitute this in for x, and this 1/2 also comes out to the front, so I'll just put another 1/2 in the front, and then u minus 1 goes right there. So how about some highlighter colors? So this 1/2 and this du is equal to this 1/2 and du right there, right? Which is the same thing as x. So x became 1/2 du. And then this part right here, right, this is what u is, and I put that there. And then dx is this right here, dx, I just established that right there, is the 1/2 du. And then change the limits of integration. So everything has a substitution. Now, you're like, well, this doesn't look any better, Mr. Jackie, and it doesn't look any better. The thing is I can't take this x and divide it by the square root of this weird thing. But now since I have this square root here, I can divide it into each one of these. Agree? So that's what I'm going to do. I'm going to modify this integrand one more time. So 1/2 and 1/2 is 1/4. Integral 1 to 9. So I'm going to do u divided by u to the 1/2 power. So think of this as the 1/2 power. So 1, we subtract the exponents, right? So it's u to the 1/2 power minus, and now I'm going to distribute this into here. So this is what I'm doing. I'm doing u to the first divided by u to the 1/2 minus 1 over u to the 1/2. That's what I'm modifying here. So I'm dividing this into each one of these. So this divided by this is here, and then 1 divided by this, I'm just going to bring it to the top. Okay, does that make any sense? So I just divided here each of those to get this. And the reason why I want it to look like this is so I can do what? Power rule backwards. All right, so add 1. I hope this isn't all like jerky frozen when this goes out. So add 1, divide. Add 1. Divide. So it'd be 2. Line 1 and 9. And then this whole thing at the end needs to be multiplied by 1/4. Okay, plugging in 9 first. 9 goes in, so it's 9 goes here, the square root of 9 is 3, raised to the third power is 27, divided by 3 would be 9, times 2, 18. 1, so it's minus 2. So when I put 9 into here, I get 18. When I put, oh, whoops, Mr. Jackie just screwed up. I got excited. I got excited, guys, but I caught my mistake. I put 9 in here, and then I put 1 in there. You got to put 9 in there as well. Okay, so 9 goes in here. Be 3 times 2 is 6. There we go. That's better. Minus. I also got excited there too. I changed my 1/2 into a 1/4. There we go. Okay, so 9 goes in here. That's 18. 9 goes in here. That's 6. Okay, now we're putting 1 in. 1 goes in here, 2/3. 1 goes in there, minus 2. That'd be 12. And then what's this? 4, negative 4/3. Is that correct? Because that'd be 6/3. So it'd be negative 4/3, but with the negative in the front, it'd be positive 4/3. Twelve is 36/3 plus 4/3. That would be 40/3 times a 4th. Answer 10/3. So that's a pretty nice answer considering all the square rooty fractiony stuff that we went through for the answer to be 3 1/3. And remember, what are we doing? We're finding units of area. So we're finding the area under the curve. All right, that was pretty exciting. Now this video would be even better if you could see my face. Ah! COVID.